right, so if you haven't already, go to these pages in the book and fill in the blanks. So the pages are page 124 for the first couple of blanks, page 126 for the blanks that are in the table. I'm going to do example 1 with you all in just a second, and then the rest of the blanks come from page 128. All right, so if you haven't done that yet, pause the video and do those problems, please. All right, so hopefully on this leading coefficient test, you have filled in the blanks about rising and falling and which directions. A quick way to remember it is that odd degree functions, the ends are going to point in opposite direction, and even degree functions, the ends are going to point in the same. And one thing that I kind of talk to my students about when I'm teaching this is that the leading coefficient tells what happens on the right. So a positive leading coefficient is going to go up on the right, and a negative leading coefficient is going to go down on the right or fall on the right and rise if it's positive. And then if it's odd, the left will do the opposite. If it's even, the left will do the same. So that's kind of a quick way to remember. So let's look at example 1. So we're going to give the right hand and left hand behavior of the graph for each function. So the end behavior. Now, one thing that I think you probably remember from algebra 2 is that the degree of a polynomial is its largest exponent, and the leading coefficient is going to be the coefficient with that variable that has the largest exponent. So if we're looking at example 1, the largest exponent is an 8, so that's an even number, so it's an even degree. So that means the ends are going to point in the same direction. And then the leading coefficient is -3. All right, so then that's going to be a negative leading coefficient. All right, and so don't forget that the leading coefficient tells you what happens on the right. So a negative means we're going to fall on the right. An even degree means the left is going to do the same thing. So this one falls left and right. All right, when we look at B, this time our leading degree is 5. So that's an odd number. Our leading coefficient is +4. So the leading coefficient tells you what happens on the right. So we're definitely going to be rising on the right. And then because it's an odd degree, the left is going to do the opposite. So this one falls on the left and rises on the right. All right, so that's my shortcut way of doing it. You can always go back and look at what you filled in the blanks earlier. So for an odd degree positive leading coefficient, you would look at what you filled in up here. So odd degree positive leading coefficient is going to be what you put in those blanks. For the first one, it was even degree negative leading coefficient. You're just going to look at what you put in on that blank. So it's up to you. Shortcut, the way I talk about it, or just go to the table, but you will have to memorize that table if you decide to use that table. All right, then let's talk about parts on this graph. So these values here where the function crosses the x-axis, those are zeros. And then the relative maximums and relative minimum values are turning points. So those blanks you filled in about zeros and turning points, that's what they're talking about on the polynomial functions. Now, multiplicity tends to be something students kind of struggle with a little bit, but what's inside the parentheses is what gives you the zero, and then the power or the number of times that it's repeated is what gives you the multiplicity. So try to keep that in mind. And one thing I would like for you to know about the multiplicity is what it tells you about the graph. Now the zeros means it's going to touch the x-axis. For the odd degree, it's going to cross it. So for an odd multiplicity, so if it just has a multiplicity of 1, it's just going to go straight through. Right? If it has an even multiplicity, it's going to touch it and then bounce back. It has an odd multiplicity, it is going to cross. That should be the 1 right there. It's going to cross it for sure. But if the multiplicity is something, it's odd, but it's greater than 1, it's going to have like a little bend in it. So that would be like a multiplicity of 3 or 5. So odd, but greater than 1, it would have like a little bend. Okay, so let's look at our examples. So for example 2 through 4, we're going to find all the real zeros of the polynomial function. So let's just start with that, and then we'll go to the other things that are new. So we found zeros before. To find a zero, or you're finding an x-intercept, or you're finding what makes the function equal to 0, so we'll just set it equal to 0. And a lot of the times you're going to factor this particular one. To factor it, we're going to factor out a common factor of 3x. Okay, sometimes you'll be able to keep factoring. Sometimes you won't be able to keep factoring. This one, I know the only way to multiply and get 1 is to use 1 and 1. There's no combination of addition or subtraction of 1 and 1 to ever give us 4. So that trinomial in the parentheses, this is not going to factor. So we can go ahead and set each factor equal to 0. All right, this one to solve, we would just divide by 3. We get that x is 0. This other one, we can use the quadratic formula if you want to, but I'm going to solve it by completing the square. So this is the old-fashioned completing the square, where you move the constant to the other side. Then you're going to add a blank to each side. We're going to take half of this 4 and square it. So that is also going to be 4. Then we'll write this in factored form. Take the square root of each side. Don't forget your plus or minus. And then we'll move that 2 over. Those are your zeros. That's 2 zeros. 1 0 is 2 plus the square root of 3. The other 0 is 2 minus the square root of 3. Oh, and there's one over here too. Sorry. So all of our zeros are 0, 2 plus the square root of 3, and 2 minus the square root of 3. All right, then we'll talk about multiplicity. So multiplicity happens when there's a repeated factor. So it's when you would have the same thing multiplied by itself again, and we don't have that in this problem. We have one factor, that's this x squared minus 4x plus 1, and we have another factor, that's the 3x. So what we would say is all of these have a multiplicity of 1. All right, and then C asks us to determine the maximum number of the maximum possible number of turning points. So hopefully you guys filled in your blanks about turning points on the front page, and that's going to be 1 less than the degree. So this one has a degree of 3, so 1 less than that, there's going to be 2 possible turning points, the most. All right, let's look at example 3. So for A, we're finding the zeros, so we'll take the function and we'll set it equal to 0. Factor out a common factor of t. Okay, this one will factor again, and it's kind of a strange one to factor, but for t to the 4th, it's going to be t squared times t squared, and then minus 3. Right, and then because that is multiplied by itself, I am going to rewrite it as t squared minus 3 quantity squared. All right, and then we'll set each of those factors equal to 0. All right, this one is already solved. This one we have a couple things to do to add the 3 and then take the positive and negative square roots. So let's list out our zeros. We have 0, and we have the square root of 3, and we have the negative square root of 3. Okay, when we go back to do the multiplicity, we look at the factors that gave us our zeros. So this factor of t gave us a 0 of 0. That t is not repeated. It doesn't have a power on it, so it has a multiplicity of 1. So 0 has a multiplicity of 1. All right, the other zeros came from this factor, and this factor does have is a repeated factor. It occurs twice, so because it has a power of 2. So these 2 zeros that came from that factor that was repeated have a multiplicity of 2. Okay, and then for our maximum possible number of turning points, we go to our original function, we look at the degree. It has a degree of 5, so the possible turning points is 1 less than that. Okay, so let's go to example 4. We are going to set that equal to 0. And find the zeros. Now, nobody likes to try and factor when you have all these fractions. So I'm going to multiply by 3, which is the common denominator, and it should cancel out all of my denominators and gives us a really easy equation to factor. All right, so if my factor is x plus 2, my 0 is negative 2. If my factor is x minus 1, my 0 is 1. So we have 2 zeros, negative 2 and 1. All right. Did either of those come from a repeated factor? So look at their factors. Did they occur more than one time? Did that factor have a power on it? They don't. So they both have a multiplicity of 1. All right, and then C, our possible number of turning points is 1 less than the degree. This one has a degree of 2, so there's 1 possible turning point. All right, so I want you guys on page 133 to 134 to do 1 through 6, 20 through 30 even, and 36 through 46 even.